everyone. So in this video, I'm going to describe the differences between populations and samples. So basically a sample is a selection of people, things, or whatever you're studying from a bigger group, which is the population of people, things, or whatever you're analyzing. So a sample is a small selection that we want to represent the population. And as you can see in my picture here, I have random circles being selected. These random circles are sporadic throughout the whole entire population. Therefore, each person in this whole circle seem to have had an equal chance of being selected because I randomly selected these people here. And what we want is we want a good representation of our population. As you can see, there are different types of people in this sample. So a population, as I was saying before, is the entire set of subjects that you're interested in. A sample is only a part of that population from what you're picking from. So you're picking this sample from the bigger population. And the goal of a sample, and this is a huge statement and a huge fact of this topic, is that you want your sample to allow you to generalize from the population. So that you want to be able to make inferences about the population. In order to generalize to the population, you must have a representative sample. So that means you, just like how I said before, you want to pick a random sample, therefore it would represent the population because every person had an equal chance of being pulled out of the population into my sample. In order to get a good representative sample, we use something called randomness. This randomness allows each subject to have an equal chance to be chosen. We want every person or thing that we're analyzing to be given an equal chance to be in the sample. When you do this and you create randomness, you create a random sample, and this allows your sample to represent the population. So the whole idea of this is to really make our conclusion about what statistics is. A statistic is making a process of inferring about the population. So when we talk about statistics, we're trying to make some kind of inference about what's actually happening with all of the people or all of the things that we're analyzing. So if you look at this picture, here's my population. I'm going to create a sample from that population. And then therefore I can use my sample in order to infer about my population. And I can do that as long as my sample was selected randomly. And again, if you guys can look at the picture, all the orange people are sporadic throughout this population. So therefore you can kind of infer that I used randomness to collect these groups of people down here. And again, I want to use that to infer anything about my population, whether it's hair color, eye color, body type, things that you like to eat, things that you like to listen to. This small sample should represent my population and therefore allow me to infer about it. So what else do I have here? I basically pulled up some key facts from the lesson. There are two things we want to talk about: parameters and statistics. Parameters have to do with the population, and statistics have to do with the samples. It's easy to remember because P starts with P and S and S. So a parameter is the actual value from the population. So it's the actual population's value. So if you wanted all the people who like chocolate ice cream in the entire world, you would have something called a parameter. It would be the parameter of all the people who like chocolate ice cream. This uses all the subjects in the population. But what if you wanted to have a smaller group? And that's probably the most realistic thing to do. We really don't work with parameters a lot in statistics because it's hard to get the whole population to cooperate. We really want to focus more on statistics because it's easier for us to grab a small sample and infer to the population from that small sample. So a statistic is a numerical description of a sample characteristic. It's used to estimate the parameter. So we use samples to estimate the parameter. So from a sample, you'll get a statistic, and that statistic will help you infer about the parameter, which is the population. So yeah, so the big idea here is that you want to create samples that are representative of the population so that you can infer about the population. So even though I have a smaller group of people, I'm going to ask them the question of what kind of ice cream they like. And if my selection of people was selected randomly and not with any bias, that could say that this little small sample should represent the population in a good way. So the amount of or proportion of people who like chocolate ice cream in this sample should be similar to the proportion of the whole population of people who like chocolate ice cream. So number one thing is to create a random sample. There are a few good ways to create a random sample. You could always pick like every 10th person that enters a building. As long as you're doing something completely random with no bias towards a certain group. There's technology we can use or random number table. Your calculator actually has a random number generator in it. And you could use that to create a random sample. You could also find random number generators online. This would allow you to create a list of random numbers. And the other thing we can use is a random number table, and I have an example of it below. But no matter what you use, a random number generator or a random number table, the steps are pretty much the same. The first step is you need to assign digits to participants, which is kind of similar to like your ID number in school. Like if the first number, say you had like 1,000 kids in school, so the first person would be 0001. And the reason why I have these many digits is because 1,000, I'm going to go all the way up to the 1,000 person, that has 4 digits here. Okay, so you first want to assign people digits, then you're going to randomly select a place to start in the table, and you're going to read the table from left to right. And you want to ignore the numbers that are out of range or the ones that repeat. So here's an example. It says from the selection of random numbers. So this is basically a picture of the random number table. You guys can Google random number tables and you'll see like a whole list of numbers, like a lot of numbers. But I just selected a small sample of the random number table. So it says select 5 employees out of a group of 625. So the first thing I want to make note of is that there are 625 people. So that means my top number is 625, my bottom number is 001, because this represents employee or person number 1. So that's your first step. Now I'm going to go ahead in my table and I'm going to analyze by 3 digits. So either you can like box or cross or whatever you want to do, but this is my first 3 digit, my next 3 digit, next one. So I'm going to keep boxing them off, and then I'm going to start to think about which ones I can use, which one should I get rid of, and so on and so forth. Okay. So 545. That is a good number. I'm going to keep 545. And the reason why I'm going to keep 545 is because it's not above 625, so it's in my range. 808 I'm not going to keep because that is above 625, so it's not in my range of numbers. 150 I will keep because that is within the 1 to 625. 727 again I'm not going to use because it's above 625. 102 I will use. 545 I'm going to have to ignore because I've already used 545 for my first number, so I don't want to repeat any employees. We always want individuals that are unique. 375 would be good because I haven't repeated it and it's not above 625. And 589 would be another good one. And there you go, 1, 2, 3, 4, 5. So this is a great way to get a random sample of people. So then I would go up and select these numbered employees and ask them the questions that I want to ask them, do the study that I want to do on them, or whatever I need to do with them. The last thing I want to talk about is samples and population. So it says for the following, describe an appropriate population characteristic, a sample, and a sample statistic. So the first question says national forests that contain bald eagles. So a good population for this example would be all national forests. A good sample would be only some national forests that I selected, randomly of course. We're analyzing bald eagles' nests. So what we could do are for our, what's the first thing they're asking? They're asking for our population characteristic. Is, for example, we could analyze the proportion of forests that have nests. So like say we discover that 100 out of 300 national forests have eagles' nests. That would be my population characteristic. A sample statistic, because that's what we get from a statistic, would be very similar to the population characteristics, except there would be a proportion of nests from the sample. So say I had 50 out of 100 that had bald eagles' nests. Another example, curfew time of boys compared to girls. So the population that we could analyze would be all boys and girls at Rocky Point. Now, that's probably unrealistic to get everyone to participate in a survey. So let's talk about what the statistic would be. Actually, the sample. We'll talk about statistic in a second. The sample would be probably some of the boys and girls at Rocky Point. You can get that sample from like standing outside the front door of school and asking every 10th person that came in, what's your curfew time? The population characteristic that we could analyze would be maybe the mean, which is the average curfew time. The statistic would be the mean curfew time of the sample. Again, so populations is everyone, sample is just a small portion of that population, and you want to make sure your sample is representative of your populations because that will allow us to make inferences about the population and allow us to make a good conclusion about the population just using a small sample of the population.